Okay, today's topic is on Pythagorean Theorem. This is one of those topics that I'm sure if your parents have uh, taken geometry before or algebra, like for sure they know this. Okay, so I'm going to go ahead and assume that you've already copied this down. At any point, you can pause the video to jot stuff down. Pythagorean Theorem states that the square of the length of a hypotenuse of a right triangle equals the sum of the squares of the length of the other two sides. So essentially, what they're saying here is if you have a right triangle that looks like this, and you build squares on each one of these sides, okay, then the sum of these two squares is equal to the sum of this square. So let's go ahead and kind of zoom in on what's going on here. So I have this triangle right here. Let's just focus on that right triangle. And on that right triangle, I know I have this length of A. If I have this length of A and I build a square on it, then I know squares have the same side. So then if this side is A, then this side is A, right? And I can find the area of that square. To find an area of a square, you go base times height. That's going to be A times A. A times A is going to be A squared. The area of that square on the left-hand side is A squared because, again, it's a square, and I know it has a height of A. Therefore, it must have a base of A. If I do the exact same thing here, then I know that this has a base of B. And since it's a square, then I know that this must also be B over here. And when I find the area of that square, I'm going to go base times height, which is B times B, and that's going to be B squared. All right, so I have the area of the legs. Here's the leg, here's the leg. I got the square over here, which is B squared. I have the square over here, which is A squared. And the theorem says that when I add both of these together, it should equal to this big square over here. Now, what's the area of that big square? Well, using the same kind of thought process that we did last time, I know that the base is C, therefore the height must be C, which means C times C, I get C squared. So what is that saying? Well, that's saying that when I have the two squares, this square plus this square, it's going to equal this square. So I can go ahead and write the formula A squared plus B squared equals C squared. It's really important. Like these two really don't matter. The one that matters is this one. The one that's by itself has to be the one that's the hypotenuse. So I'm going to go ahead and highlight that this is the 90 degrees right here. If this is the 90 degrees, then that means this is a leg, this is a leg. That means the other one, the one over here, must be the hypotenuse. The C is the one that needs to go by itself. I don't care about the A and the B. If you switch the order, it's not a big deal. But the one that needs to go by itself is the hypotenuse. I'll put a little thought bubble right here. Hypotenuse is the one that needs to go by itself. I'll highlight that in pink as well. Hey, because this formula only works for right triangles, it only works for right triangles because you need a hypotenuse, right? You need to know which one's the one that's by itself. If you don't have a hypotenuse, then you don't know which one's the one that needs to go by itself. So this formula only works if you have a right triangle. All right, go ahead and take a minute. You're going to go ahead and jot down these four examples. Press pause on the video, jot them down. It shouldn't take you that long. We're just going to go ahead and jump in. And all of these problems for today are going to be right triangles, so I can use the Pythagorean theorem. What the Pythagorean theorem allows us to do is if I have 2 out of the 3 sides in a right triangle, then I can find the third side using the Pythagorean theorem. Okay, so let's go ahead and see. I have a right triangle. Since I have a right triangle, then I know that this is the hypotenuse. And since I'm missing one of the sides of the hypotenuse, then I can go ahead and use my formula. I know that A squared plus B squared is equal to C squared. Again, I really don't care which one's A or B. The only one that matters to me is that the hypotenuse needs to be the C. So that means in this case, the X is going to be the one that's going to be by itself. The other ones I can label however I want. So I'm going to go ahead and say that this one's my A and this one's my B. Again, you can switch the order of the A and the B and it's not going to matter. So I'm going to go ahead and use my formula and I'm going to write that 3 squared plus my B is 4. So I'm going to write 4 squared equals, and in this case, my C is going to be X squared. Let's go ahead and calculate this. I get 3 squared, which is 9, plus 4 squared, which is 16, is equal to x squared. 9 plus 16, I'm going to get 25, is equal to x squared. That means there's this number out here that when you square it, the answer is 25. We haven't really talked about this, but when you square root, technically you really should get two answers, and we'll talk about that later. So I'm going to square root both sides. The square root of 25 technically is plus or minus 5. What I mean by that is if I take 5 and I square it, then the answer is 25. If I take negative 5 and I square it, the answer is also 25. But because we're talking about lengths of sides of triangles, then it doesn't make sense for the length to be negative 5. So in this case, our answer is just going to be positive 5. So I know if that I have a length of 3, a 4, then that means this side, this hypotenuse must be a 5. All right, I'm just going to ignore the negative answers for today. We'll go back into that negative answer because it will come back to bite us later. But for today, whenever I take a square root, I'm just going to consider the positive answers because I know my lengths need to be positive. All right. All right, let's go ahead and try this again. We're going to go through the same thing. I have a right triangle. I have 2 out of the 3 sides of a right triangle. Notice that these are sides and these are not angles. That's why we're using Pythagorean Theorem and we're not adding them up to 180 degrees. 180 degrees are for angles. For right triangles, and if I want sides, then I should be using Pythagorean Theorem. The important part of Pythagorean Theorem is knowing which one is your hypotenuse. So if that's the 90 degrees, that means this is my hypotenuse, which means this one is going to be my C. So I'm going to go ahead and use the formula a squared plus b squared equals c squared. Again, I don't care which one's my A or which one's my B, so I'm going to go ahead and write that this is A, this one's B. The one that does matter is the C, though. The C needs to go by itself. Okay, the hypotenuse needs to go by itself. That's going to be important later on. So I'm just going to go ahead and start plugging in my numbers. I get 12 squared plus 5 squared equals x squared. I'm just going to go ahead and start solving this. This is 144 plus 25 equals x squared. This is why it's so important that you know those perfect squares like we mentioned earlier in the previous example. I'm going to add these up. I get 169 is equal to x squared. We're going to square root both sides. Normally when you square root, you need to put in a plus or minus. But again, today we're just going to focus on the positive answers. Square root of 169 is 13. And so therefore, this side must be 13 on this right triangle. All right, we're going to try 2 more. Pretty basic ones. Let's see. I'm going to go ahead and realize that this is my 90 degrees. That means this one is my hypotenuse, which means this one must be my C. It doesn't matter the order. In fact, I was going to call that A just to switch it up on you. I'm going to call that one B because again, these two really don't matter. What matters is the hypotenuse has to be alone. So I'm going to go ahead and write A squared plus B squared equals C squared. My A is 9 squared plus my B is 7 squared equals my C is x squared. 9 squared, that's 81, plus 7 squared, that's 49, is equal to x squared. I'm going to add those up. I believe I get 130 is equal to x squared. I'm going to square root both sides. These are going to cancel, and I'm left with an x, and the answer is going to be x equals the square root of 130. Now, what you should do at this point is there's going to be one of 2 things. They're either going to ask you to round to the nearest hundredth. Okay, if you're going to round to the nearest hundredth, you're going to type in square root of 130 into your calculator and find the decimal approximation. If they don't tell you to round to the nearest hundredth, then you're going to have to simplify that radical. So that means we're going to be doing the lesson from before. So I'm going to check all my perfect squares and see if there's anything that goes into the 130. So I would start at 121, nope. 100, nope. 81, nope. 64, nope. 49, no. What's left? 36 doesn't go into 130. 25 does not go into 130. 16 does not go into 130. 9 doesn't go into 130. 4 doesn't go into 130. We're stuck here, right? Like there's nothing that goes into that 130. If you were going to break it down to do it this way, right? into its factor tree. Let's see, 130, that's 10 times 13, and that's 2 times 5. I don't see any partners, right? If you don't see any partners, then that means the answer is all going to go on the inside. 2 times 5 times 13, which is, again, 130. There's nothing you can do. It's already simplified. You can't do anything with it, okay? All right, so let's go on to the next one. We're going to go ahead and calculate this one. Same process. Here is my 90 degrees. Here is my hypotenuse. That means this one's my C. I'm gonna call this one my A, and I'm going to call this one my B. Let's see, I'm going to go A squared plus B squared equals C squared. A squared, that's 10 squared plus 5 squared equals X squared. All I did was I plugged in my A, B, and C. That gives me 100 plus 25 is equal to X squared. So 125 is equal to X squared. I'm going to square root both sides. These are going to cancel. I get X equals the square root of 125. Remember, that should be a plus or minus, but we're going to ignore that for right now. I'm going to look at all my biggest perfect squares and see what goes into it. So we start with the top and move our way to the bottom. The biggest one is 121. That's a no. 100, no. 81, no. 64, no. 49, no. What's after 49? 36 does not go into 125, but 25 does. So we do need to split this up. This 125 is the same thing as 25 times 5. And I can go ahead and split that up now to square root of 25 times the square root of 5. And the square root of 25, I know the square root of 25. The square root of 25 is just 5. If you wanted to break it down the old way, right, 125 is the same thing as 25 times 5. And 25 is the same thing as 5 times 5, and that's as far as I can break it down. So these are the numbers that I'm left over with, and I do have a partner here, which means that 5 is going to pop to the outside. I don't have a partner for this 5, so that's going to be a loner. That's going to stay on the inside. You get 5 right 5. Both ways, you should get the same answer, okay? From now on, I'm going to stop breaking this down like this. I'm going to work with these ones over here, just because it's a little bit faster and it saves me some time. But you can go ahead and break down your radicals however you want. Okay, we are going to go to the back side. We got 5 more problems to do. Go ahead and take a minute, pause the video, and copy down the problems. We're going to just go ahead and jump in. Let's see, I'm going to go ahead and do the exact same thing I did before. So therefore, this is the 90 degrees. This is my hypotenuse. Therefore, this one must be my C. So I'm going to go ahead and start writing down my formula. That means this one's my A and this one's my B. And I know that some of you guys did that wrong because some of you guys always think like, oh, the X is always the C. That is not true. So when I start plugging in my A squared plus B squared equals C squared, I'm going to write 6 squared plus X squared is equal to 10 squared. So it changes a little bit this time. 6 squared, that's 36, plus X squared is equal to 100. I'm going to subtract 36 on each side. I get X squared is equal to 64. And I square root both sides. Thankfully, I know the square root of 64. The square root of 64 is just 8. And so I get my answer that way. So, hey, on these, sometimes the X is not going to be your hypotenuse, and you got to make sure you put the X in the right spot. It doesn't matter if X is here or here. X just cannot go here, okay? Not in this case because it's not the hypotenuse. Really, really important that we pick off that hypotenuse, okay? So same thing here. I'm going to go ahead and pick this off right here. Here is my 90 degrees. This one is my hypotenuse. So that means this one's going to be my C. I'm going to go ahead and call this one A. I'm going to call this one B. Formula is A squared plus B squared equals C squared. That means X squared plus 5 squared is equal to 13 squared. X squared plus 25 is equal to 169. Subtract 25 on each side, I get X squared is equal to 144. Take the square root of both sides, because that's how you get rid of a squared. You get X equals 12. Thankfully, there's no approximation or anything like that. You just go ahead and just plug it in. All right, we got 3 more problems, almost done. Here's my 90 degrees. Here's my hypotenuse. That means this one's going to be my C. That means I can go ahead and call this one A and this one B. Again, that order does not matter as long as you know that this one is your C. The pink one is the one that matters. So I'm going to go ahead and write A squared plus B squared equals C squared. That means 7 squared plus X squared is going to equal 9 squared. 49 plus X squared equals 81. I'm going to subtract 49 from each side. I get X squared is equal to, this becomes a 7, that becomes an 11. I get 32. X, square root both sides. X equals the square root of 32. Unfortunately, I don't know the square root of 32, and I should try to break it down. Starting from 32, let's see, the biggest perfect square is 25. That definitely doesn't go into 32. Then it's 16. 16 does go into 32. So let me go ahead and break that down. This square root of 32 is the same thing as the square root of 16 times 2. That's how I get the 32. Why am I doing that? Well, because I know the square root of 16, right? The square root of 16 is just 4. Square root of 2. Again, if you didn't like that, you can go ahead and take that 32, break it all the way down into its parent tree, and you should get the exact same answers as what I got over here. Okay, last one. We're going to go ahead and I have two sides of a triangle. We're trying to find the third. I have a right triangle. That means this time C is my hypotenuse, which means my X is my hypotenuse. Okay, so that one's the one that's got to go by itself. I'm going to call this one A. I'm going to call this one B. I get A squared plus B squared equals C squared. 7 squared plus 6 squared equals X squared. 7 squared is 49 plus 36 equals X squared. 49 plus 36, I believe that's 85, is equal to X squared. So X must be equal to the square root of 85. Check your perfect squares. Let's see if anything goes into it. So 81 is the biggest one. That's definitely way too big. 81 won't go into 85. The next one is 49, and nope, that doesn't work. The next one is 36. 36 does not go into 85. 25 doesn't go into 85. 16 doesn't go into 85. 9 does not go into 85, and neither does 4. So I think that's it. We are stuck. The square root of 85 is simplified. Just to kind of verify, because it's always kind of scary when you're not able to simplify it, right? 85 is the same thing as 5 times what? 5 times 17. And I can't break down the 5 and I can't break down the 17. So these are the ones that I'm left down with. And then 5 times 17 is just 85. And so we're kind of right back where we started. Okay. All right, last one. Last one says Damien rides his bike 10 miles north, then 6 miles east. How far is he from his home, rounded to the nearest tenth of a mile? Okay, well, we're going to go ahead and draw a picture. Here's Damien's house. This is where he started off from. There's Damien's house. It's going to say he's going to go 10 miles north. That means from here, he went 10 miles this way. And then he went 6 miles east. That means from here, he went 6 miles this way. So right now, Damien is right over here. The question is, how far is he from his house, rounded to the tenth of a mile? The distance from him to his house is going to be from here's his house all the way to where he's at now. So if you notice, this is making a right triangle right here. And I'm trying to figure out how much is this distance, that red line distance. So if I want to go ahead and solve this, I'm making a right triangle. Here's my 90 degrees. Here's my hypotenuse. Because it's a right triangle and I got 2 out of the 3 sides, I can go ahead and use the Pythagorean Theorem, which says a squared plus b squared equals c squared. Remember, this one is your C because that's your hypotenuse. That means the other ones don't matter. I'm going to call this one A and I'm going to call this one B. So when I start plugging this in, I get 10 squared plus 6 squared equals x squared. 100 plus 36 is equal to x squared. That gives me 136 is equal to x squared. We're going to go ahead and square root both sides. Now, in this case, they told me to round to the nearest hundredth. So I'm going to go ahead and plug in the square root of 136 into my calculator right now. And I get 11.661903. 11.661903. But they asked me to round to the nearest hundredth. This is the tenths. This is the hundredths place. That means my answer right now is 11.66. I need to look at the next number. If that number is 5 or more, then that 66 turns into a 67. I add 1. If it is not 5 or more, then that 66 stays a 66. And right now I'm looking at the number 1. That is not going to bump it up. That means my answer is going to stay 11.66 is, and I guess this should be miles, right? 11.66 miles is how far he is from his house. Okay, that's all the time I have for today. If you have any questions, as always, feel free to ask.